So, my name is Ben. I'm a back-end engineer here at KeepSafe, and I'm going to talk about how we built a system to identify user groups that we want to run experiments on. So, or as I like to call it, A/B testing on the cheap. So, there we go. So, as Zuhair mentioned, we've had quite a bit of traction. We've had 30 million users. Google Analytics is just too expensive, and we have all this data, and we want to be able to use it to answer questions about the behavior without hiring data scientists. And the first challenge we run into is how do we pull users out? How do we find who we want to experiment on? So, next slide, please. So the first thing we had was a tool that we built called Switchboard. Now, Switchboard was wonderful because it was so fast and so simple. It was one single PHP file. And all of our experiment groups were defined in code. It was simple. It was fast. This worked because KeepSafe was a single device product. And that was it. All the logic was in the app. There was no back end. And we could ship it by Tuesday. So it was fantastic, and we didn't have to think about it. Now, fast forward till maybe 6 months ago, no slide, KeepSafe became a multi-device product. We introduced a backend with user accounts. We introduced file synchronization, so people could use their phone and their tablet at the same time. And Switchboard no longer solved this problem, because instead, what we would have is two users with two different devices who would see two different experiences. Maybe one group would see a paywall on their iPhone, but not on their iPad. So we needed a new tool. But we also wanted to ship it Tuesday. Next slide. So what we needed was the sorting hat, which, are any of you Harry Potter readers? Yeah. Okay. Okay, let's go on. So sorting hat. Its one job, its one and only job is to sort users into these groups. They're grouped into cohorts by lists of criteria. You know, a cohort could be consisting of a number of users. It could be a set of users that join on a given time span, or any other arbitrary predicates. A cohort is defined by a JSON document, so we no longer had to go and write code to define groups. But since we didn't have such tight time constraints as we did when we were building Switchboard, we wanted to put a little more thought into this. We wanted to be able to handle not just the groups that we thought of today and put into code, but we wanted to be able to handle groups that we thought of 6 months from now. We didn't want to just handle data points that we knew about today, but we wanted to be able to handle whatever data the client sent at us in the future without necessarily knowing about it while we were building the system. So an example of a cohort would be this JSON document, which probably nobody can read. Keep going. So a sorting hat partitions users by learning facts about them. And a fact is anything that a client sends to the system. And it could be things like the operating system, the app version, the sign-up date, how many photos they have, how many photos they've imported in a given session. It could be literally any data, and we can match on it. Go next. So one of the big questions I had in my mind was, how do we make it fast? Switchboard was fantastic because it was so simple. There was no database to talk to. It was so fast, we could actually put it on the direct startup path of our app, and we wanted to maintain that. So how did we do that? No, not yet. We used Amazon Web Services. It was so wonderful to work with these tools because we could put together a distributed queuing. We could get a consistent, expandable database with DynamoDB. We have fast, expandable caching with Elasticache, and we didn't have to build any of it. It was cheap. We were able to build quickly because we chose to use Clojure, which, for any of you who have not heard of it, it's a Lisp that runs on the Java virtual machine. And this let us write a small amount of code that did a lot of things. And I guess the trick that we used to make it fast was we just denormalized data. When the user sends enough data to become, and they're selected to join a cohort, we write it to a database in the background. This is called fan out on write. because it doesn't really matter if the user sees this new update the minute they become eligible for it. And of course, we have to measure everything. So scroll next, please. So just as an example, these tools worked so easily. This is a graph of the latencies in Sorting Hat. And you can see from this red line, that's the 95% of requests are satisfied in under 30 milliseconds, which I'm very happy with because it lets us continue to use this tool in the startup of our app without really impacting startup time too much. Go next, please. So what do we do with it? As Zuhair mentioned, we used Sorting Hat to run our payment experiment, which was an interesting endeavor. We ended up defining 18 cohorts, testing 6 different price points with 3 different categories of users. And this is something that would have been, I couldn't even imagine how we would do that with Google Analytics or with any other out-of-the-box tool, but with Sorting Hat, it was as easy as sending some JSON up to the server. And it was something that we could build quickly because we didn't have to do any analytics ourselves. This tool does nothing but segment users. Doesn't do any data tracking, doesn't do any history. We just send it off to Amplitude. And that's about all we have. We just let somebody else handle the hard work and let me get back to my work building our Android app or building our backend or whatever else we need to do. So that's it. That's Sorting Hat. It's simple, not much more to say about it.